Okay, so let's do a little bit of review. We didn't have much time yesterday, any time really, to practice going over our vocab. So Friday we learned vocab, and then yesterday we were supposed to learn our theorems and what's true about all those vocab words. So let's start by just going over the vocab, okay? So from Friday, we learned all these words, these combinations of words. We learned alternate interior, same side exterior, corresponding. We reviewed vertical and linear pair, all of that. So when I give you two angles, from now on you should be able to tell me what is their relationship, and the word describes their relationship. So if you look at these two angles right here, these are on alternate sides of the transversal. One is on the left and one is on the right. Then you ask yourself, are they interior, like between the lines, or are they exterior, like outside the lines? Like if these lines were to crush, like if these lines were to collapse, if they were to collapse, I know you can't see me do that, then the question is whether those stars would get crushed or not, if those lines were to collapse, and they wouldn't get crushed. So they are alternate exterior angles. All right, let's take a look at what we have behind here. These are not alternate because they are both to the right, well, no, to the left of our transversal. They're both to the left of our transversal. So these would be same side, and these are exterior angles because they're also on the outside of those lines. If those lines were to collapse, those stars would not get crushed. All right, next one. Right there in that picture, those are alternate because one's on the left and one's on the right, and those are interior angles. They are inside the lines. So on this one, we've got alternate interior angles. This is the only one that doesn't really fit the mold. This one doesn't say alternate or same side in its name. It doesn't say interior or exterior. And the word for this one is corresponding. And I remember them, corresponding angles. I nickname them the sliding angles. It's because you could take that angle and you could slide it directly into that star's position. So they're in corresponding positions. I also kind of think of it as if I were to take this cluster of angles and then copy and paste it right below. If I copied and pasted it here, this star would end up in this star's spot. They're in corresponding spots. They're both at the top left, right? They're both at the top left. So they're in corresponding positions. Okay. Next one, that one's old news. That one doesn't even use the other line. You see how this one doesn't even use that line at all? That's old news. Those are vertical angles. This one doesn't even use this line at all. Also old news, linear pair, so you need to be able to recognize a linear pair at all times. And what's the only one we haven't done? Same side interior angles. This one is not a linear pair. It's same side interior angles. They're both to the right and they are inside the lines. If those lines were to close in, those stars would get crushed. Okay? Yesterday, what we were supposed to learn is that if we have parallel lines, then some cool things happen. If we have parallel lines, then, are y'all talking? Sorry, I want to, Truett had a fire drill? Okay. Thank you for coming. If our lines are parallel, we were going to sort these into columns. So we would have found out that alternate exterior angles are congruent, same side exterior angles are supplementary, alternate interior angles are congruent, same side interior angles are supplementary, corresponding are congruent, vertical are congruent, and then linear pair are supplementary. So when we see that pattern, we look and see, how are we going to memorize all this stuff? That's a lot of words, and I have to remember which ones are congruent and which ones are supplementary. But then we see that supplementary and same side all start with an S. So we can remember that if it starts with an S, they're supposed to add up to 180, they're supplementary. And if it doesn't start with an S, well, they're congruent. The only exception to the rule, as you know, is linear pair. But we'll forgive him for being an exception because he has the word line in his name. And when we hear line, we think 180. Automatically we think 180. So that's why we'll forgive him for being in that column but not starting with an S. I wish he did. Okay, so that was really yesterday's lesson in a nutshell. So parallel lines at the top. I'm definitely going to work I'm definitely going to work these, but let me know what else you want me to work other than those. Sorry, what were you asking? The reason that 16 through 19 aren't on there is because there's so many different answer combinations, right? There's multiple answers, and so we didn't type those up because it would just get confusing trying to find your answer and seeing if it was the right one. There was just too many multiple answers. So if you want me to work one of those, I can, but we did purposely not put those on there. Now, the really, really important thing that we learned yesterday was that all of those things that we learned, congruent and supplementary, those columns, those go out the window if our lines are not parallel. So if it doesn't say something like this at the beginning of your problem, you wouldn't be able to work it at all. So I just want to make sure that we're clear on that. Okay, AB is parallel to CD, and AD is parallel to BC. ACD is 110, and ACD is 28. Find the measure of every angle. Okay, so what I would start doing is I would just start finding all the ones that match 110. I would fill them all in. Okay, 110, 110, 110, 110. Because these are corresponding and these are corresponding. Then jump over here. 110 and then vertical angles 110. And then angle 8, 110, and then that angle 110. So now I filled in every angle in the picture that's 110. Now let's use our 28 and see what we can do with our 28. With our 28, we're going to use alternate interior angles to our advantage. 28, 28. Alternate interior angles are congruent, so you can put 28, 28. So now all we have to deal with are 2 and 9. And for 2 and 9, we're just going to get a little bit creative. We know that this angle and this angle, well, we could really just use linear pair. But let me use these two because these use our new vocab words. Those two angles are same side interior angles. That starts with an S. That means those angles are supplementary. So I know 110 plus 28 plus something equals 180. So all I have to do is go to my calculator and subtract from 180. I subtract 180 minus 110 minus 28. I'm going to get 42. And then we use alternate interior angles. If that one's 42, then angle 9 is 42. And now we've filled in almost every angle in the picture. We need to do angle 5. That's just angle addition because angle 5 is the same as that angle. So 42 plus 28 is 70. So that one's 70. It's just the linear pair to 110. 70, 70, 70, 70, 70, 70. Linear pairs, lots of them. All right, so that's that one. The next one you wanted me to do was number 24. Oops, sorry. 24. Now remember, in this picture, you only have two choices. They are either congruent or they're supplementary. You have no other choices. So let's look at what angles they give us. Angle 2 and angle 8. Angle 2 and angle 8. First thing you do is write down the vocab word. Alternate, oops, I was about to put interior. Alternate exterior angles. If it doesn't start with an S, then they are congruent. So those two angles are congruent. X squared minus 6x equals 3x plus 22. Then it's a factoring problem, so you move everything to one side. X squared minus 9x minus 22 equals 0, and then you factor that one. You're going to use 11 and 2, but I'll let you factor it on your own. So the moral of the story is that in this whole section, you're either setting them equal or you're adding to equal 180. There's no other choices, A or B. Okay, let's make sure that we have time for today's lesson. So we're going to get into today's lesson, which is where we take everything from yesterday and we just use the converse of it. Now, oh my goodness, what does converse mean? Because it's been a while. Who would like to say out loud what converse means? Thank you, Quan. Go ahead, Quan. Anyone?
My mic isn't working.
Oh, you'll have to look into that.
Use mine.
Anyone, what does it mean?
Reverse.
Reverse, thank you. Converse means reverse. If it is sunny outside, then it is hot. The converse would be if it is hot, then it is sunny, right? You're just switching the hypothesis
Enable your camera.
in the conclusion. All right. So the converses are used to do the opposite. Instead of proving that two angles are congruent, we're going to use the fact that they're congruent to prove that the lines are parallel. We're going to prove what yesterday was the given, okay? If K is parallel to M, then corresponding angles are congruent. The converse is, if corresponding angles are congruent, then K is parallel to M.
He's raising his hand.
Oh, I'm sorry. What do you need? All right. So today, we are not going to assume our lines are parallel. Are they parallel? I don't know. The jury is still out. It is our job to prove they're parallel using what we're given. So we're going to start off by not knowing they're parallel. In this picture, is A parallel to B? I don't know. And so we're going to use whatever they give us to determine whether they're guilty or not guilty of being parallel. So I could go through all of these, but I'm just going to let you know that, what? It's just, does that make sense? Searching for proof so that we can really show that they're parallel. All right, so these are all the words you've already learned. All I did was on each slide, I just wrote the converse. If angle 1 plus angle 2 equals 180, then K is parallel to M. So let's decide. I give you two pictures. In each picture, do you have enough proof to decide if K is parallel to M or not? So I'm going to give you a second to look at that. Don't say anything out loud yet, please. What are you doing to decide if they're parallel? What are you doing with those two numbers? Anybody?
Yep, 180.
You're adding them. Everyone should be adding those numbers. You should be adding. This is an addition problem. What do you get in the green picture? What is 65 plus 98? You don't have to raise your hand. You can just talk because I don't know who came first.
No, not 180.
It's not 180. I love your answer because you did not even have to tell me what it equals. All we care about is that it's not 180. So these angles are not supplementary. Therefore, is K parallel to M? The answer is no. And then surprise, surprise, in the other picture they are supplementary. So is K parallel to M? Yes, sirree, Bob, it sure is. You get how we're proving them parallel using our angles? Hopefully.
Yes.
All right, we know the rest of the story, right? If corresponding angles are congruent, then K is parallel to M. I would just write that in every blank. So I'm not going to go through these because you already know them. Let's try this practice problem. Determine if A is parallel to B and justify your answer. Let's do number 1 together and then I'll let you think about the other ones. Angle 2 is congruent to angle 6. I want you, the first thing you should do is write down the vocab word. Angle 2 and angle 6, vocab word. Alternate interior angles. Alternate interior angles, that doesn't start with an S. If it doesn't start with an S, then they're congruent. Angle 2 is congruent to angle 6. Are they doing what they're supposed to be doing? They're alternate interior and they're congruent. Ding, ding, ding. They're doing what they're supposed to be doing. So we're going to say yes, A is parallel to B. And the reason why, it says justify your answer. If alternate interior angles are congruent, then our lines are parallel. So I just used very shorthand notation. I wrote an if-then sentence. If those angles are congruent, then our lines are parallel. Let's do the next one. Let's just keep doing it together. Because we are a team, guys. Angle 3 and angle 4. Angle 3 is congruent to angle 4. What's the vocab word for 3 and 4?
Linear pair.
Yes, good. Those are a linear pair. Now wait a minute. If linear pairs are congruent, what's the measure of each angle?
90.
90, 90. If this angle is 90 and this angle is 90, does that force A to be parallel to B? Yes or no question? Let me pose this question. No. Could I erase A from my picture? If I erased A, would angle 3 and angle 4 still be there?
Yes.
Yeah.
Yes.
That means they have nothing to do with line A. So we absolutely could not say that A is parallel to B. That information is not proof. That's like the prosecutor. He presents his case and the judge still says not guilty because your proof was not good enough. Number 2, the proof is not good enough. Number 3, 7 plus 3 equals 180. We always start by writing the vocab word. 7 and 3. They're, again, alternate. Yeah. Now, wait a minute. What are alternate interior angles supposed to do if the lines are parallel? They're supposed to be congruent. So they're not doing what they're supposed to be doing. That means that they do not force the lines to be parallel, because that's not what the theorem says. It says if they're congruent, the lines are parallel.
Miss Tanton?
Yeah.
Technically, in the situation where angle 7 and angle 3 both equal 90, it could be parallel, but is it like in all circumstances that we want?
Correct. Always. If you can find one counterexample, then your answer is no. So this one could be 80, this one could be 100, and that would not make A parallel to B. Good question. There's one time that they would be parallel, and that's if 7 and 3 were both 90. But that's only one time out of an infinite number of times. Okay? All right.
Oh, I'm breathing that.
Angle 1 and angle 5. Alternate exterior angles. That doesn't start with an S. That means they're supposed to be congruent. Are they doing what they're supposed to be doing? Congruent. Check. Check. So this one's a yes. And our answer is if alternate exterior angles are congruent, then our lines are parallel. Let's try a few more. For real this time, I'll let you do them by yourself, and then we'll talk about it in just a minute. So no one say anything. Decide what your answer is to 5, 6, and 7. Angle 3 are supplementary. Does that make A parallel to B? Yes. And the reason is if same side interior angles are supplementary, then our lines are parallel. Same side interior starts with an S, and they are doing what they're supposed to be doing. They're supplementary. That's why our answer is yes. Awesome job. What are 8 and 6?
I got it wrong.
You totally got it right. No, you got it right. 8 and 6 are corresponding angles. Corresponding angles are supposed to be congruent. They're doing what they're supposed to be doing. Therefore, the answer is yes. Good job. So, I agree with you that these are vertical angles. These are vertical angles, and vertical angles are supposed to be congruent, right? So they're doing what they're supposed to be doing. But wait a minute. Do angles 2 and 8 have anything to do with B? Do angles 2 and 8 have anything to do with line B? No, they have nothing to do with line B. So because B is not involved, he is not involved. He's not an accomplice to this crime. So he is not involved. So we would say no, the lines are not parallel. That one's a no because B is not. We always start by labeling what we're given. EDF is 28. EDA is 100.
We have to go.
Okay, go ahead and go. And CAD is 53.
Hi guys.
Parallel lines, well, maybe parallel lines, we don't know yet. There's the lines and there's the transversal. If they really are parallel, then this plus this should equal 180, if they really are parallel. So you're just adding those numbers together. Goodbye. You're adding those numbers together, and you're determining, oh, they add up to 181. Therefore, AC is not parallel to DF because they did not add up to 180.